how many number of tangents can be drawn from an external point? We can draw 2 tangents, right? So, if we take this is the circle C, okay, let's take this is the circle C I have drawn, and the external point is B, okay. So, if the point is inside the circle, how many tangents can be drawn? We cannot draw any tangents, since all the points which is passing inside the circle have the 2 touching points on the circle. So, for the tangent line should have only one single touching point on the circle, okay. So, the point is an external, okay. So, from the B, you can draw one BC line is a one tangent, another line is BD line is another tangent. From the external point, we can draw 2 tangents, okay. So, here I have drawn the 2 tangents from the point B, okay. That is touching the C at a single point, that is a C point here. And another tangent line is touching at D, okay. So, this theorem says that if you draw a tangent from the external point, and that 2 tangents distance from the point to the circle, right, it is same. That means it's a BC equal to BD, okay. So, we need to prove now BC equal to BD, okay. Simple. The length of the tangent from an external point to a circle are equal, okay. So, it's BC is equal to BD, okay. That we need to prove. So, A is the center of the circle, right? So, I have drawn the construct line from the B to A, okay? So, we need to prove that the triangle BCA and triangle BDA are both are congruent triangles. If you prove that congruent triangles, both are congruent triangles, if you prove that, then we can say that the length of the BC equal to length of the BD, okay. So, we know that these 2 triangles are the right angle triangles, right. So, here we have the 90 degrees and here also it is 90 degrees. Why? Just now we proved, right. So, if you draw from the center to the radius, okay, this is the radius distance R, right. So, this is the radius, even this is the radius. So, the radius to the tangent line, okay, always perpendicular. Why it is perpendicular? So, from the point to the line, the minimum distance is always having the perpendicular, okay. That is with that theory we have proved just now. So, the any line drawn other than this, okay, it is just crossing the circle and it has the longer distance or higher than the length AC, okay. So, the AC is the shortest distance. The shortest distance always having the perpendicular, okay. See, the first triangle BDA and triangle BCA, okay. So, in these 2 triangles we see BA equal to BA, right. Why? It's a common, right. So, common, okay. Then AC equal to AD, right. Why? Both are radius. Radius of the circle is same, okay. What is third one? So, angle C equal to angle D, right. In these 2 triangles, isn't it? Angle C is equal to angle D. Why? So, tangent to the radius is always 90 degrees, right. So, both are 90 degrees angles, same. So, we know that this is a right angle triangle here, it is a right angle triangle here, okay. And the hypotenuse is same. Hypotenuse is the BA for the both, right. So, hypotenuse is same and one more side is same, right. Okay. So, it's through the RHS, we can say that these 2 triangles are congruent triangles, okay. So, why it is a congruent? So, if you take the right angle here, just I will draw here a C, okay. If one hypotenuse and one side, okay, one side same, automatically with the Pythagoras theorem, others also will be same. So, that the 3 sides will be the same, okay, to the triangle. If 3 sides are the same and it is in so then it has the 90 degrees also, right. So, then we can say that these 2 triangles are the congruent triangles, right. so that it is equal triangles. Therefore, we can either triangle BDA, BDA. How do you write the equivalent triangles? Equal sign and this, right, like this, right? So it is equivalent to triangle BCA. Okay. So with this we can say that PQ equal to, so with this we can say that BC is equal to BD, right? Okay. Therefore BC equal to BD. Okay. So once we have proved it. So now I have drawn a circle here, that is the C circle, okay. So now I am drawing another concentric circle, right? So the concentric circle is always having the same center, okay. So I'm drawing another circle here, okay, which having the same center. If I am highlighting, right, whichever moving the circle, right, this all circles are the concentric circles, okay. So having the same centers, okay, when we are moving here to all, okay. So what this theorem says, right, if you take another concentric circle, okay. So I'm just stopping here. So the D is another concentric circle, okay. So if you draw a tangent to this D, okay, to any point, tangent means what, right? So tangents, if I'm drawing to the tangent to the leg, right? So I have drawn the tangent to this circle, the smaller circle here. If you draw tangent to the smaller circle, it touches to the one point to the C, right? So I'm just marking that point here, okay? So this is the point touching to the smaller circle, and this is the point, 2 points are touching to the larger circle. So what it says, right? This is what we are calling for the circle C. This is called the chord, right? This GH is the chord length of the larger circle, right? So it divides into the equal parts. That means GF distance is equivalent to the F and H distance, okay? This is what theorem says, okay? So when we have the two concentric circles, if you draw the chord, okay, tangent to the smaller circle, okay, that equally bisect the chord length, okay? That means GF is equal to FH, okay? So now we will prove this one. So I have drawn, see things, whatever I explained here, right? I have drawn the two concentric circles. The center of the circle is A and the chord is E and ED, okay? So it bisects this line at the C, right? So C is the tangent point for the smaller circle, okay? So if we read out this, prove that in two concentric circles, the chord of the larger circle, this is the chord of the larger circle, okay, which touches the smaller circle, okay, which touches the smaller, it is just touching to the smaller circle, okay. It is just touching to the smaller circle means it's a tangent to the smaller circle, okay. So it's the bisected at the point of contact. Wherever it is a point of contact, it just bisect, okay. Bisect means it's equally bisecting the chord length, okay. Now we need to prove here. What we need to prove here? We need to prove here EC equal to CD, right? So I'm drawing some construction lines here, just joining the E and A, and just D and A, okay? Either it's so I just joined the three lines, okay? I just joined the E and A and A and D and A and C, okay? So we know that here we have the 90 degrees, right? Why it is 90 degrees? It is a tangent to the smaller circle, and this is the radius for the smaller circle, right? So angle between this radius connecting to that point line and the tangent is 90 degrees, right? So now we need to prove that. So here, simple here triangle ACD, okay? So this ACD and triangle ACE, okay? ACE, okay? So if you prove these two triangles are congruent triangles, then it is easily proving that EC is equal to CD, right? So we will prove these two triangles are congruent triangles, okay? So for the first condition, right? For the triangle ACD and ACE, right? So angle C equal to angle C, okay? It is there. So both we have marked with a single point here, C, right? So both are equal because both are 90 degrees angle, okay? From these two triangles, okay? Then another is C, AE equal to AD. Why? It's the radius, right? It's the radius, okay? And another right here, and AC equal to AC. Why? It is a common, and also radius of the smaller circle, okay? It is the radius of the smaller circle, okay? So now we have seen here, right? So this is the radius and hypotenuse, right? So hypotenuse is same and one side is same, and both are having the right angle triangles. So with RHS we can say that the two triangles are the congruent triangles. So therefore we have proved that it is EC equal to CD, right? That's all. So all the theorems, right, you need to prove that both triangles are congruent triangles, so that we can easily prove that the corresponding edges are equal, okay? So the below picture is explaining the construction of the problem, okay? So what is telling here? PQ is the chord of length 8 centimeters of a circle of radius 5 centimeters, okay? So the largest circle here, whichever I am showing here, right? So this circle, right? Okay. So this circle, right? This circle having the radius of 5 centimeter and the chord length. There is a given one chord, okay? In that circle, he has given the chord, okay? The chord is PQ. The chord length is here. What he has given is given 8 centimeter. That means PQ is equal. Just write down whatever they have given, okay? So they have given that PQ equal to 8 centimeters. Now also given the radius of the largest circle. That's I'm just mentioning. C is the circle here. That is PO. Okay, PO equal to 5 centimeters. Okay. Then what is also the tangents at a point PQ intersects at a point T. Okay. So to the circles, okay, he has drawn the two tangents from the point T. Okay. So the tangent point on the circle is P and Q, okay? Find the length of the TP, okay? So we need to find the length of the TP. Just observe, okay? Don't see my method, okay? Yourself you can see sometime on the problem. You will understand what to be done, okay? Now also I am seeing here this problem straight away now, okay? What do you know, okay? So you know one thing, okay, this is the 90 degrees. Why it is 90 degrees? It is a tangent and this is the radius line for the circle, okay. What else you know? Okay, this is also 90 degrees, okay. Okay, if we just use the two triangles, okay, you can find out very easily. Let's take first the triangle. Let's take the triangle PRO, okay. PRO, okay. So if you see this is the right angle at the R, right? So we know that what is the PR distance? PR is the half of the chord length, right? So from the external point T, TP equal to TQ, same, right? And if you say if you see here TR, okay, TR is also common for these two triangles, right? If the hypotenuse and one side is equal and these two are the right angle here, and these two triangles are the congruent triangles. That's why the PR distance equal to the RQ distance, right? PR distance equal to RQ distance. With that we can see that its the total length is 8 centimeters is given. Half of that 8 by 2 is 4 centimeters, right? So PR we know that it's the 4 centimeters here, okay? So from the triangle PRO, it's the right angle at the R. We know PR is 4 centimeters and PO is 5 centimeters. What is RO then? Okay, we need to use the Pythagoras theorem. What is the Pythagoras theorem here? It is a PO square equal to PR square plus RO square. Okay. What is the hypotenuse here? 5, right? 5 square is 25. Okay. What is the PR here? It's a 4, right? 4 square is 16. Okay. Plus RO we need to find. Okay. RO square. Okay. If you do it RO here, so 25 minus 16, if you take it here, it come 9, and square root of it, we'll get it is 3 centimeters. Okay. So RO is 3 centimeters. So we know now RO. I'm just writing here RO is 3 here. Okay. Now see clearly here. Okay. Now in this triangle, we know all the sides. This is 4 and this is 3 and this is 5. Okay. Now let's take TR distance. We don't know, right? Let's take this distance as X. Okay. Which are the tangent length, that also we do not know, right? Let's take this distance as Y. Okay. Whichever we do not know, right? We need to take all this. So now use this triangle. Okay. Here. Which triangle? Okay. I'm just rewriting here. See. If you use the triangle TRP. Okay. TRP. Triangle TRP, if you use it, and how we can write hypotenuse is the Y, right? So Y square equal to, so this is X, right? So X square plus 4 square is 16. Okay. So we can write this equation, right? Now we will take this largest triangle. Okay. That is triangle TPO. Okay. Now we will take triangle TPO. Okay. If you take what is the hypotenuse in this triangle, TO is the hypotenuse, right? So hypotenuse square means X plus 3 whole square equal to sum of the other two sides. What is the other two sides here? It is a Y here, right? So Y square plus 5 square. What is the 5 square? 25. Okay. From this equation, Y square is equal to X square plus 16, right? Let's substitute here. Okay. Let's expand this left side term here. Okay. I'm just expanding it quickly. Okay. So let's expand this term. Okay. X plus the whole square is it is A plus B whole square thing. That means we need to have the X square plus 3 square is 9 plus 2 into X into 3. Right? Equal to, what is the Y square? Y square can be substituted with X square. Right? So Y square can be written like X square plus 16 plus 25, right? Okay. So if you simplify it, so both sides, the X square terms get cancelled. So here 9 plus 3 into 2, 6x equal to 41, right? So 6x equal to 41 minus 9, okay? 41 minus 9 equal to how much? It's 10. If you subtract, it becomes 31 and 1 32, right? Okay. So X equal to 32 by 6. Okay. If you cancel with the 2, 3, 16 by 3, right? So X is equal to 16 by 3. So we found that X is equal to 16 by 3, right? So X is equal to 16 by 3, okay? If you substitute this one into this equation, okay, what is this equation shows? Y square is equal to X square plus 16. That means Y equal to square root, right? Square root of X square plus 16, right? So if you substitute here, X square equal to 16 by 3, okay? 16 by 3 whole square plus 16, right? So what you do is just you take the 16 common here from these two. Simply, okay? If you take the common 16 here, so it left with 116 here, and the 3 square is 9 here, okay? Plus 1 here, right? Okay. What is the square root for the 16? 4, right? Let's take the 4 outside. 4 into square root of. So 16 plus 1, okay? if you take LCM here, in these two, if you take the LCM 9 here, okay, you'll get 16 plus 9, right? So that I'm rewriting here. So 4 into square root of 69 is 25 by 9, right? Okay. So 4 into, what is this square root of 9? It's 5 by 3, right? So it is 20 by 3. Clear? So finally our answer is 20 by 3. Okay. So here a quadrilateral drawn ABCD is the quadrilateral, okay, drawn to circumscribe a circle, okay. That means see, this is a circle C, okay. So this is a circle C and he has drawn one quadrilateral, okay. Quadrilateral he has drawn, okay, that is forming ABCD, okay. Quadrilateral is forming, okay. At the boundaries of the circle he has drawn. That means all the lines are the tangent to the circles, okay. So AB is the line is the one tangent, and BC is the another tangent, and CD is another tangent, and DA is another tangent, okay. As for the figure, we can identify that is okay. And those touching points to the circle is, so for the AB tangent, right, the P is the touching point, and BC tangent, Q is the touching point, and CD is the tangent touching point is R, okay. Similarly, DA touching point is S, okay. So what is need to prove, right? AB plus CD equal to, okay. That means what is this AB? So this is AB, okay. AB plus CD is equal to AD and CB, okay. This is BC or CB, okay. We need to prove that, okay. That means opposite sides sum, okay, equivalent to other opposite two sides, right? If you take the A point, right, it looks like no external point, right, outside the circle, and we have drawn the two tangents from the point A. That is, AP is the one tangent line and AS is the another tangent line. So what do you prove now just before on theorem, okay? So if you draw a tangents from the external point, okay, the tangent distance both are same, okay. That means AP equal to AS, okay. Understand, right? So what you can write while writing in this stepwise, right? You need to write that A is the external point, drawn tangents to the circle, like AP is the one tangent and AS is another tangent, okay. So theorem shows that these two tangents are having the equal lengths. That means AP equal to AS, right? Similarly, from the point B, okay, if you take the point B, okay, it is BP equal to, from the point B also we have drawn the two tangents, right? So it's BP equal to BQ, okay. Similarly, from the point C, if you see, it is a CQ equal to CR, okay. And if you take from the point D, similarly, it is a DR equal to DS, okay. So this all the distances are same. Now what do you need to prove here? Let's take the left hand side of this one, okay. So what, and then we will get the right hand side one, okay. Left hand side AB plus CD, okay. So AB, right? AB can split to the two, right? Like AP and PB, right? Okay. So AB can be split to the AP and PB. Similarly, CD, okay, CD can split to the CR and DR, right? Okay. So that means, right, the sum of this AB and CD are written. We need to prove the two other sides, right? Then while writing here, we will write the other sides. So this AP equal to SA, right? That's what we have shown here. So AP is equal to SA or AS. Yeah. See, AP is equal to AS. Okay. So AP is equal to AS. We'll write here. Like PB, what do you write? PB is equal to this QB, right? BQ or, okay. So this is a BQ. Plus, what is this CR? The CR equal to CQ. plus this dr equal to ds. So we have changed it, everything, okay. From the above 4 equations, we have changed the terms, okay. Now we will rearrange these 3 things, okay. Like if we take the AS, okay, AS, do we have the DS here? Yes, we have the DS here, okay. So this AS and DS will write together, like AS plus DS, okay, plus this BQ and CQ will write it, okay, BQ plus CQ will write it here, okay. Now, if you see AS plus DS means is the full length of this, right? That is, it's equal to AD, right? So, it is AD plus, similarly, BQ, CQ. If you take BQ and CQ, okay? What is the sum of this one? It's total distance, right? Like BC, okay? BC. So, we have proved that AB plus AD equal to AD plus BC, okay? If you stuck anywhere in the solving any of the problem we are here, okay, write in the comment box, okay. I will try to explain in the next video, or I will take a short video, or I will take live classes for the free, okay. So doubt may be the anything, okay, it may be small or big, okay, whatever is there in your mind, please write in the comment section, okay. Don't hesitate to write, okay. Anything you write, I will try to address that, okay. Thank you for watching. Like and share with your friends. Thank you.